Guys, it got all weird. Okay, so for those of you guys just joining us, we were talking about letter A and trying to solve. For letter B, what's going on? Yeah, what are you stuck on? They didn't give you the function itself. So I think that might be my dilemma. Let's go ahead and make R equal to theta. Yeah, you could go ahead and throw in. So then that would be 1/2 pi over 2 to pi of theta squared d theta. And solve, solve, solve. So for letter B, if R does just equal theta, which is going to be some version of that. It could have been 2 theta, 3 theta, 1/2 theta, but it is going to be some sort of theta. That's the only way that you get that spiral that's ever increasing, or a function of theta. What are we going to do for B now? Plug it into what equation? But there is no x. Okay, so x equals R cosine theta. So I can say x equals theta cosine theta. What are we supposed to be setting it equal to? -3. We're going to solve that by hand. The answer is no, definitely not. So how are you going to use your calculator? Okay, go. It's easy to say plug it in and solve, but it's another matter to actually be able to do it. What mode are you guys going to right now? I think you better go to function. Remember, in polar, there's no intersect feature. There's no zero feature. I would go to function mode. Now, what are you going to do in function mode? 0? But there's no 0 anywhere. Okay, so you can add the 3 to the other side and solve for a 0. Look for the intercepts in between pi over 2 and pi. You can make your window, right? X min, X max. Is that okay? You can make your window because you're going to be graphing x cosine x. So you could make x min pi over 2 and x max pi. You could add the 3 and then find the zeros of x cosine x plus 3. Or you could graph y1 and y2 and find the intersection in between here and here. Did you graph both functions? Did you graph this and that? So either you graph this as y1. Guys, this is just like super, not basic, but it's important to know how to use your calculator for an AP test, right? Thanks. So our two options are either from this and needing to solve this. Our two options our two options are either to have theta cosine theta plus 3 equals 0 and solve for the zeros, or our option is to make y1 equal to theta cosine theta, obviously with x's, y2 equal to -3 and find the intersect. So either use your 0 feature, stop throwing things, or use your intersect feature. What did you guys find when you did the 0 or the intersect? Hold on, pause. You need to have your window be between pi over 2 and pi. So you need to make your window x min pi over 2, x max pi, because you need to zero in on that. So then we end up with theta equals, sorry, what? Okay. Oh, because one of the 2's was rounded. Got it. So 2169. Okay. Find the angle theta that corresponds to the point P. That's the reason I didn't want to quite round it yet, right? Because I just want to find the angle. So how are we going to find, oh, we already did that. How are we going to find the y coordinate then? So you can make this something like A. Is that okay? So we can just plug it into A times sine of A. Okay, that wasn't too bad, yeah? You were just missing the function? Okay, so what do you guys get for y? Just A sine of A? Okay, so we have our theta is equal to 3.022. Y is equal to 0. Anybody back them up? Okay, we're in radians, yeah? So what's going on in part C when it says a particle is now traveling along the polar curve? Ooh. Sorry, go ahead.
How do you do the STO as the A? So once you get the intersect, do you just click like enter?
You have to have something solved on the graph first. So either 0 identified, intersect identified, and then just do second quit, hit STO.
Second quit what?
Second quit, hit STO. STO on the left-hand side, a little bit above the bottom, and then type in a letter, A or B or C or D. Then hit enter. But you have to have the intersect or the 0 or the max or the min. You have to have it solved for on your grapher before you hit second quit. It can't just be whatever random point you traced to. It needs to be actually solved with a function on the graph. So you need to have intersect being identified, 0 being identified. You need the word there to show that the grapher just found it. Then do second quit, hit the STO, make it a letter. You got it. Okay, a particle is traveling along the polar curve. Its position is x of t, y of t, and we know d theta dt is 2. Find dy dt at the instant that theta is 2 pi over 3 and interpret the meaning of your answer in the context of the problem. All right, what do you guys think? Theta equation? We have r equals theta. Okay. X and y, do we need both? No. What do we need? Why do we just need y? Okay. So to find dy dt, hold on, I can't find that unless I have, and what did we just say y was? R. Okay, so dy dt, I have to take y prime, yeah? So what's y prime? Good, second d first. Plus first d second. But what's the struggle? What have you not done? Thank you. What else did we not do?
Yeah, and then it should be second.
Okay. I taught you guys last year second d first plus first d second, right?
Yeah.
Just some of you naturally do first d second first every time. Okay. Okay. Thank you for trying to read my mind. Noah was doing first d second, and so I heard his cosine. I wrote his cosine when I was doing second d first. So I was just making sure that last year I taught second d first plus first d second. So thank you, I found the mistake. I think we've all identified the mistake, and I think we're fixing the mistake. Second, sine, d first, 1, right? Plus, first, d second. But what I'm asking is, why has no one said d theta dt yet? Now, a few of you might have been trying to say that. That's what I was truly asking. Thank you. Yes, our product rule is good. Very proud. But why didn't we write d theta dt? Why do we need d theta dt? Because we're taking the derivative in terms of t of both sides. True? This is like a y and this is like an x. If I'm doing this implicitly, don't I need a u prime? What's the derivative of theta? So those of you that were trying to interrupt because you were trying to say d theta dt, that's a great job. I hadn't heard any d theta dt's up until that point. And so I was just writing the product rule, and then I was going to go ahead and check and see if anyone had forgotten to think about d theta dt. So thank you for checking my product rule first. Now that's good. Does it make sense why we need d theta dt's on both expressions? Because on this one, we took the derivative of a theta, 1 d theta dt. And the second one, we took the derivative of sine of theta. Derivative of the outside is cosine of theta times derivative of the inside, d theta dt. What was really nice in the problem up above? They gave you something that you should have known you needed to use. Okay. So now as we go to plug in, when theta equals 2 pi over 3, and we also know our clue of d theta dt is equal to 2, can't I just plug and chug? So I end up with dy dt. You guys go and let's just not say any math out loud. And simplify with the unit circle. 2 pi over 3 is in the second quadrant, yeah? What sign at 2 pi over 3? Positive square root of 3 over 2 times 2 is just going to be square root of 3. Then we have our 2 pi over 3. Cosine is going to be negative 1/2. Second quadrant, negative value. Negative 1/2 times 2 reduces. I just have negative 2 pi over 3. As you guys know in long answer, though, how simplified did you need that? You just needed the trig plugged in, right? Now hold on. That's great. We did find dy dt, but what's the struggle as to what the problem asks for us to complete our task? Okay. What does this mean? The change in y value? No. I heard vertical velocity and I heard dropping. Rising but negative? True, but you should know whether it's positive or negative, right? 2 pi is going to be 6.28-ish. 6.28-ish divided by 3 is going to be 2-ish. 2-ish is going to be greater than 1-ish, right? So is it positive or is it negative? Negative, so it's less than 0. So we know something is decreasing, right? What's decreasing? You could say the position is dropping vertically. You could say that. You can't say velocity. A few of you are mixing velocity and decreasing. Why is that horribly illegal? Velocity already is the derivative. I can't use a derivative word like increasing, decreasing with velocity. True? So I could either say the vertical velocity is negative, or I could say something to the effect of, I can't just say decreasing because I have horizontal, I have vertical, and I have polar. I can't just say position, but I can put in vertical. So I can say the particles, vertical position, is decreasing at a rate, right? I don't think there were any units the entire way through, so I could say at a rate of root 3 minus pi over 3. Wouldn't have any units. Can anybody think of another way of saying that, though? You could say the vertical velocity is negative. You could almost say the particle is dropping. Why could you say dropping at a rate of? Dropping is talking about vertical height, yeah. You could say dropping as well. Okay, but do we kind of get how we can't use velocity and decreasing, but we still have to somehow get in some sort of vertical, some sort of height, some sort of y measurement, and not just x and r? Okay. Guys, was the polar part of this very hard? You had some vector stuff here at the bottom. You guys didn't know what the function was here up above, so that got us a little lost. But in homework last night, where did we get stuck? Okay. There could have been a few different places we got stuck. I want you guys to take a second and just re-evaluate. We did this a little too fast for some of you yesterday. I want you to look at this example one more time as to why there's a plus in the middle and as to why the bounds are different. Take a second. And as I'm pulling up the homework for the evens from last night, I want you guys to re-evaluate just a little bit from yesterday. this last example and why it's set up the way it is. We have an Endeavor card, and that Endeavor card talks about area between and area shared. And in that Endeavor card, when we're talking about the area between, which could also be area shared, sometimes there's an addition going on and sometimes there's a subtraction going on. As you look at this example, why is there addition instead of our normal area between, which is subtraction? What was different in the wording, in the question, in the graph? Go. The one that you're looking at? Oh, are you guys not looking at it? It didn't freeze? Oh, I tried to freeze it. E for effort, F in success. There we go. Too many students think E for effort means A in success, and that's not necessarily true. It's a hard fact of life, but important to learn. Why is it adding?
Because if you kept the circle go outside the area. So you stop it and add the area.
So John's seeing if we kept on going with the circle, first of all, it's not going to be accurate. That's true. Why are we even going to the circle 1 second and the cardioid the next? What was the wording? Inside both, like shared in both. I think that's what the homework problem said, right? What's shared? I don't know what you mean by out of it. Once the two curves intersect at A, I hear you. What are you saying?
Like, would the cardioid extend out a bit more with the loop? Or?
They intersect there.
Yes,
and then the cardioid's inside, the circle's outside. Before the cardioid's outside, the circle's inside.
Like, if you stop the circle at A,
right?
The cardioid be inside that area or more outside?
The point from the pole to the intersection of A is a straight line. That straight line on one side, all of the area is going to the circle. And that straight line, the area on the other side, goes straight to the cardioid. There's a curve and a dimple, and there's a curve and a dimple. That's okay. So then coming back, we're adding because 1 second we need to be going to the circle. The next second we need to be going to the cardioid. We need the bounds to be different because the circle is between 0 to the intersection, which they said was 4 pi over 3, right? And then the intersection to, why did I guess pi? Even though I should probably double check that, but why did I guess pi? It seems to stop halfway through the graph, right?
Yeah.
And if it's stopping halfway through the graph, well, what's my period of 3 plus 2 cosine theta? What's the period of 3 plus 2 cosine theta, the actual graph I'm looking at right now? 0 to 2 pi. Some of you guys might be like, but what if it's one of those ones where it goes around twice? Well, we checked on Lima-sans yesterday. You could actually graph him by hand, but he doesn't. He completes one full cycle in that 2 pi. So halfway would be pi. So that wasn't just a guess, that was an actual answer. I just need to replace my A with the actual intersection that they gave me, and they were really nice and said 4 pi over 3. So now that I have this all set up, isn't the intersection at, oh, thank you. I didn't keep reading. What would be different? Is my sound on? What would be different if there was a subtraction they were being put together? They would not be area between, right? These are totally separate. 1 second it's a circle, the next second it's the cardioid, and we're adding the two together. What would be different for them to be inside in one integral with a subtraction? If we needed to find not area shared, but area between. Because between, I would need to take the red radius going all the way out and the blue radius going part way out and subtract the two. That would be like area between that we did back when we were just doing rectangular functions. So the difference in our Endeavor card when you guys look at it is the wording. 1 second we see between, and the next second we see shared or we see inside both. 1 second we see between, and the next second we see shared or inside both. Do you guys see the difference between adding and subtracting? Here's the example of the subtracting. The subtracting, if I wanted the between, I needed to go out. Subtract the two to get between. With that, let's go ahead and peek at homework and let's see what was going on and how we got so stuck. 11.3, here are the evens. Stop me right away if something isn't making sense. Here's our first even, number 42. Which number 42, it was more of kind of like the problem we started off with deriving and such, right? All we need is y prime of theta over x prime of theta, but we couldn't do y prime or x prime until we actually make y or x. How many of you guys actually use the formula as far as, right, but the product rule of the r cosine theta. How many of you guys use the formula? The product rule already done. How many of you guys actually did the product rule? Okay. You don't remember what you did? Okay. Are we good? Yeah. Because the derivative's good?
Where did I get 6?
Second D first would be right? Then we have plus first. They saw the sine squared and cosine squared and said, no, let's get them all in terms of cosine, because otherwise, so they went ahead and changed sine squared to be 1 minus cosine squared. Then we have plus 3 cosine minus 3 cosine squared. At which point a negative 3 cosine squared and a negative 3 cosine squared, there it is. So they just changed sine squared to be 1 minus cosine squared and simplified. Huh? Oh, not technically. Not technically. But if you had to factor, like if you had to factor something looking for vertical or horizontal tangent, then you might have wanted to have this nice and factored, in which case you couldn't have kept a sine squared and a cosine because you wouldn't have known what to do with it. Does that make sense? If you needed to factor that, you needed to change it to cosine squareds. Okay, on number 50, now we got back into area, right? Okay. Final answer would have been pi minus 3 root 3 over 2. Guys, you know what this means. This means you could have done it by, look at where I'm pointing. You could have done it by hand. But if it was a calculator problem, you would have ended there, right? But they could have asked for it on a non-calculator part, and hence why we have to memorize our power-reducing formulas, yeah? Any questions about the setup, though? Was your function just 2 sine theta minus 1? Okay, so this wasn't an area between or an area shared, right? Okay. And so the point of this one was the bounds, and those could have also been the zeros, right? They were the zeros. Number 64 is E and number 66 is D. Are there any other evens that are past 66? Okay. Okay. Any questions on 64 or 66? Because this is literally just the letter. Okay. No questions on 64 or 66? Okay. What's going on in 74? This is weird. There's not even an integral. What's going on in the context of the problem? Why is there no integral? What's the question being asked? Okay, so you're trying to show that both are the same. So then isn't it just a, hey, who's x, let's take his prime product rule, who's y, let's take his prime product rule, and then what are they doing? Well, foiling, but the difference of squares, and so a lot of stuff tends to combine. Then do you see how maybe they might be using some sine squared plus cosine squared as one stuff? And then going ahead and saying, wait a minute, I know who he is, he's r, and that's going to be dr d theta. Anyway. Okay, I know that the evens make it look like the homework was easy, but it wasn't. And why? Because I gave you guys a lot of the area problems as odds. So, in the odds, where did we get stuck? Oh, question on 74? Oh, thank you. Go ahead, Kyle, what's your question on 74? You guys can start checking 1 through 4.
Okay, so the second bullet point, so it's f prime of theta plus theta squared. How do you want to that to second part?
Difference of squares. This guy's going to be squared, which you see. This guy's going to be squared, which you see. There's going to be minus 2 of this times this, but over here there's going to be a plus 2 of that times that, so they cancel out. So foiling, and then combining the like terms. And the middle from here, the outer plus inner, and the middle from here, the outer plus inner, and canceling out. Yeah, Katrina. All right, questions on the odds, or maybe we could do the quick quiz, the 1 through 4. Oh, Alan, go ahead. 53? Okay, good. Shared by the circle r equals 2 in the cardioid?
So if it's shared, you have to out.
Can you go ahead and read me the functions real quick, Alan?
Yeah. It was r equals 2 and r equals 2 parentheses 1 minus cosine theta.
And the wording was?
Shared. Yes.
Who am I graphing right now? What kind of shape is 2 minus 2 cosine? Cardioid. Not an inner loop because the 2's are the same. Cosine goes between -1 and 1. So these radii are going to have a range of 0 to 4. It's never going to go negative, so I know no inner loop. I'm going to go ahead and add on a few radii just to be prepared and be ready. But when I go to plug in and think about this shape, when I plug in 0, cosine is 1. That's the lowest. So actually this function starts right here. Now how do I know exactly where these intersect? I do know it goes to here. Because when cosine is at pi, that'd be -1, which would be 2 plus 2 is 4. How do I know when they intersect? Couldn't I do the bounds if I needed to, if you weren't quite sure? And couldn't you set 2 equal to 2 times 1 minus cosine of theta, which would end up being... So I know that it's going to intersect here. And here. It said shared, right? So shared, aren't I looking at this little guy right here? That would be outside on the circle side. This would be outside on the cardioid side. P.S. They can ask that. They can say, what's the area within the cardioid but outside the circle? What's the area outside the cardioid but inside the circle? But shared. Oh, there you go. Does it make sense why I'm drawing blue lines right now?
Yes.
Because it touches the cardioid until the straight line, the intersection point, pi over 2, right? Then what do I need to do? Draw black. Why am I just going to go, for sake of simplicity, until pi? I can double it, and I can use the symmetry. So I can say that my area is going to equal double the integral, double. Good. You guys are remembering that there is a formula for area within. That was my next question. So 2 times 1/2, the integral. 0 to pi over 2 of what function?
2 minus cardioid.
Which would be?
2 minus 2 theta squared.
Good. And that only gives me this little piece right here, right? Well, technically 2 times gives me both of those, right? Then d theta. And then I also need the 1/2 for
It would be
the interval pi over 2 pi. And then you would just plug in your cardioid. And yes, you guys are noticing you can distribute the 2 and cancel out, and then you have to solve if you do it by hand or you plug it in your calculator if you do it by calculator. But does it make sense? If you follow the motion of the curves, then you see that the 2 curves really do intersect at that point, and so it's totally fine. It's not one of those false intersections like yesterday. Questions on the process for 53? Another question. What else do you have?
Can you scroll down? There's a C.
The TA must not have seen it. Thank you for letting me know. I'll see if I can find it. Any other questions on problems? $40 or 50.
Within the cardioid, no, within the circle, but outside the cardioid.
Is it the same shape though?
It's no.
Okay.
The dimple isn't on the inside of the loop. This is my shape.
Okay. What are my functions for it?
Cosine theta and 1 plus cosine theta.
That was 57. Jason, what was it? 3 cosine theta?
Plus cosine.
Oh, 1 plus. I was like, I missed the 1 somehow. Okay. Your 1 plus cosine will be at its largest to begin with, right? And then it dimples in and it goes back out. At pi over 2, it would be at 1, yeah? There's your cardioid. For 3 cosine theta, it starts 1, yeah. Cosine of 0 is 1. 1 times 3 is 3, right? Oh, sorry. I appreciate it. Thank you. Okay. Now where's it go? It goes to 0. Right? It goes out to negative? Oh, it goes back. Do you guys find the intersections? Is it pi over 2 and 3 pi over 2? No, not quite. Where were your intersections? You guys should have found them, yeah? Pi over 3 and... So then you could just... Well, I'm assuming there would be symmetry though, yeah? Okay. So then with your intersections, and Jason, you found it to be pi over 3. And it was a true intersection. They both rotate the same way, so we're okay. There's no, like, the other guy's rotating the opposite direction. They said inside the circle and outside the cardioid? Okay. So if that's what you're trying to find, I would go ahead and think about with maybe like a highlighter so you guys can see it a little bit clearer. This is what I want, right? But the dilemma is whenever I go to do an integral, I'm going to go all the way out to blue, and I don't want all the way out to blue, but I need to start there, right? But what do I need to take away to get the in-between? I need to subtract, hence the in-between idea, subtract all the red. The nice thing is these two are rotating the same direction, so I'm allowed to basically steal and use the bounds that we've already found. So then my area is going to equal double I have times my 1/2, and I have my bounds from 0 to pi over 3. Since they operate or are working on the exact same intervals, and I can go ahead and just take my outer function, which would be my 3 cosine theta, my outer radius, and then you have to square minus, because it'd be that minus 0, kind of like a washer. You have to do the whole minus the hollow. Outer radius, then you have the inner radius of
1 plus cosine theta squared, and then you d theta.
Okay, you guys have already noticed the test is on Friday tomorrow. Oh, I didn't write on the. I talked about it in 0 period. We did not work on the review yet, so your homework tonight is the review. Your homework tonight is the review. Come tomorrow with the questions, and we'll have a work period tomorrow. Sound good?